Hello everyone, I am Vishnu BH here to present the topic about fundamentals of UV visible spectroscopy, emphasis to electromagnetic spectrum and electronic transition. These are my contents. Electromagnetic radiation. The propagation of light in waves involves both electrical and magnetic forces, which gives rise to common class, namely electromagnetic radiation. The electromagnetic radiation can be described as a wave occurring simultaneously in electric and magnetic fields, and it can also be described as if it consisted of particles called quanta or photons. The wave theory is most concerns us here. You can see the diagram here. Electromagnetic spectrum. The spectrum is an ordered sequence of wavelength. The spectrum of entire range of wavelength is called as electromagnetic radiation spectrum. The band obtained by arranging various types of electromagnetic radiations in order of their increasing wavelength or decreasing frequencies is called as electromagnetic spectrum. Different regions of electromagnetic spectrum are cosmic rays, gamma rays, X rays, UV rays, visible light, IR microwaves, radar, television, radio waves, and electric current. We can see in the diagram different regions of electromagnetic spectrum with different wavelengths. Different regions of electromagnetic spectrum. This table represents that region cosmic rays wavelength is 5 into 10 to the power of minus 3 nanometer, frequency 3 into 10 to the power of 11, and energy 9.5 into 10 to the power of 8. For gamma rays, 10 to the power of minus 3 to 0.14 nanometer wavelength, and frequency is 3 into 10 to the power of 7, and energy is 9.5 into 10 to the power of 5. Similarly, we have for X-rays, far UV, near UV, visible, near IR, mid IR, far IR, microwave radar, UV visible spectroscopy. UV visible spectroscopy requires electromagnetic radiation of high energy. The visible region corresponds to 400 to 800 nanometer and ultraviolet region 200 to 400 nanometer. It is based on absorption. Absorption depends on wavelength, radiation, and structure of compounds. It also relates with Beer-Lambert's law. Beer-Lambert's law. It states that absorbance is directly proportional to concentration of solution. A is equal to epsilon L into C, where A absorbance, C concentration, L path length, epsilon molar absorptivity. Electronic transition, pi to pi star transition, sigma to sigma star transition, n to pi star transition, n to sigma star transition, sigma to sigma star transition, ligand field transition. These are the main types of electronic transition. Here we can see the diagram. Sigma to sigma star transition. Sigma electron from bonding orbital is excited to corresponding antibonding orbital, sigma star. The energy required is large for this transition. Example, methane has CH bond only and can undergo sigma to sigma star transition and shows absorbance maxima at 125 nanometer. Pi to pi star transition. Pi electron is a bonding orbital is excited to corresponding antibonding orbital pi star. Compounds containing multiple bonds like alkynes, carbonyl, nitriles, aromatic compounds, etc. undergo pi to pi star transition. Alkenes generally absorb in the region of 170 to 205 nanometer. It is the best example for pi to pi star transition. N to sigma star transition. Saturated compounds containing atoms with lone pair of electrons like oxygen, nitrogen, sulfur, and halogens are capable of N to sigma star transition. This transition usually requires less energy than sigma to sigma star transition. The number of organic functional group within N to sigma star peaks in UV region is small, one that is 150 to 250 nanometer. N to pi star transition. An electron from non-bonding orbital is promoted to antibonding pi star orbital. Compounds containing double bond involving heteroatoms C double bond O, C triple bond O, N double bond O under such transition. N to pi star transition require minimum energy and show absorption at longer wavelength around 300 nanometer. Sigma to pi star transition. These electronic transitions are forbidden transitions and are only theoretically possible. Thus, N to sigma star and pi to pi star electron transitions show absorption in a region about 200 nanometer, which is accessible to UV visible spectrophotometer. Ligand field transition. It is based on molecular orbital. Metal ligand charge transfer and ligand metal charge transfer are the two types. Ligand metal charge transfer. Ligand with high energy lone pair and it is high oxidation state. Metal ligand strengthened. Metal ligand charge transfer. Ligand with low lying and pi star orbitals. It has low oxidation state. Metal ligand strengthened. These are my references. Thank you.